Vice President Product Line Electromobility, what does that mean? It means that I'm globally responsible for long-term product strategy and business development of Volvo Trucks electric product lines. It also means that I basically dream about high energy efficient drive lines and energy storage systems with the maximized energy density, because that is what we are so dependent on. So this is my favorite topic, and that's why I'm so happy to be here today. And I could go on for hours, but the plan is that I will try to stick to half an hour to 40 minutes. And why not do like this, that please feel free to, or do we need a mic? Should we take the questions afterwards, or you recommend to do that? It's better. Okay, let's do that then. I go on for 30 minutes approximately, and you save the questions to the end. And the topic of today is what I will be focusing on is why we believe, and Volvo Trucks believe, in electromobility, and what the benefit to society is, the challenges that we have, and of course I will talk a little bit about where we are in the process and the upcoming offering that we are presenting later on this year, or putting out on the market later on this year. So some technical parts, of course, for those who are interested. I hope that this is something that you will be able to refer to, and that there will be a lot of interesting things along the presentation. But if not, by the end at the Q&A, please feel free to ask basically anything around electromobility, and I will try to answer that as good as I can, to the extent that I'm allowed to as well. I cannot talk about future launches, I cannot talk about pricing and those kind of things, so please respect that. Okay, first I would like to check a little bit. Who here is working in the automotive industry directly one way or the other? Good, okay. And how many of you are working with electromobility more specifically? 2 at least, 3, 4 maybe. Good to know. How many of you drive an electric car privately? Good. I wish I was able to say yes to that, but I'm not. I'm dedicated to one brand. I don't know. I don't have to say which one, but I'm dedicated to one brand, and at the moment there are no offers available to me, at least. So, but hopefully I will get there. Good. Then I know a little bit more about you guys. And what do you know about Volvo Trucks then? Well, I will just give you some key figures for those who don't know. Volvo Trucks is the second largest global heavy-duty truck brand, and we provide a wide range of medium to heavy-duty trucks in 140 countries, supported by about 2,300 dealers and service points. We are, of course, our main market in Europe, but also North America is a very significant market to us. But we are present in South America, in Africa, in Asia, and Australia as well. Last year was a record year for us. We sold 127,000 trucks worldwide, Volvo branded trucks. We are part of the Volvo Group, for those who didn't know that. We've been around since a couple of years, since 1928, and basically since then been building trucks to move things. And our ambition is really to be the world-leading provider of heavy-duty sustainable transport. And that is sort of the fundamental of the work that we do, together with our core values, quality, safety, and environmental care, hence the topic of today. So, why trucks? How many of you are on a daily basis thinking of what the world would look like without any trucks? I do. But the base is that I imagine where we would be without truck. It would actually mean that it's not necessarily that the human race would cease to exist, but there will be a lot of issues, a lot of things that we take for granted in our everyday life, in the way we are living. The flat screens on the wall, the technical devices that we have, the food on the table, the medical things to the hospitals, the building material to our houses and so forth. And that is maybe, to some extent, could be basic or obvious, but it is basic for why we have trucks in society. They are there to transport things, and the main driver for having trucks in society is actually the way we live, our habits, and the way we consume things. So to be honest, the best way to impact the climate in a positive way is to reduce consumption and or at least change the way we consume things. Having that said, it's also very important that truck business is to some extent very low margin business. Normally a transport company has margins around 2 to 3%, so they can simply not afford to run trucks out in society without any purpose. It's basically just me and a couple of my colleagues that maybe run trucks for fun, but the majority of trucks out there, they really have a purpose. So that is important to understand. And transportations is many times seen as the circulatory system of society, meaning that it provides the nature, it provides the things we need, and it takes away the disposals, refuse vehicles carrying out everything that we consume during the of the body, like blood. It's also things that it should just work and preferably should not be seen, and that's a challenge that we have, of course. But without trucks, the society would not function. Something is not working. Is it this that stopped working? Men det funkar. Should have checked that long time ago. Okay. So, what is then the climate impact of trucks? We all know that transportation, it is necessary, but we should do our utmost to make sure that we reduce the climate impact of these transports. Europe has set up targets on CO2 reductions for 2020, 2030, and 2050 in relation to what emissions, CO2 emissions we had in 1919. So far, we have exceeded our target towards 2020, which is good. But towards 2030, we need to do a lot more. Our ambition is to reduce CO2 emissions with 40%, and we are around 2022, so this is quite short time. We need to accelerate our work to reduce the impact and the CO2 impact. And hopefully what you can see here is then that there are certain sectors where we are doing well when it comes to energy supply, electricity, where we see a big improvement, especially thanks to solar power that has become more accessible and a lot cheaper and much more efficient. The industry as such is also reducing their impact on CO2. However, when it comes to transports, it's not working in the right direction. So what is then the CO2 impact of road transport on the heavy-duty transport in Europe? Well, about 20% of the road-related CO2 emissions in Europe, 27%, is connected to heavy-duty transports. And unfortunately, these have increased since 1990 by 25%, which of course is not sustainable. And we understand that we need to do something about it, and we really need to change. We acknowledge that we are a part of the problem, but we also are very dedicated to be part of solution and try to do something about it. And there are basically what we have at Volvo Trucks. We have a two-path strategy, working in two areas to reduce the climate impact of heavy-duty transport. One is working with energy efficiency along the complete value chain. It's both about how much emissions the truck from tailpipe emits from tailpipe, but it also during the complete industrial production system. It also, of course, when it comes to transport efficiency, how can we improve efficiency of the transport as such? And that is something that we've been working for quite many years. Examples of that is how we in Sweden or in Scandinavia have worked hard to allow heavier and longer transport, which in reality per transported ton kilometer reduces CO2 emissions. And the second alternative is, of course, working with alternative fuels. There are a lot of alternative fuels that could potentially help to reduce CO2 emissions from the heavy-duty truck transport industry, but some of them are less promising than the others. We evaluate fuels all the time from several different categories. It's the availability of the fuel as such, the climate impact of the fuel, and the use of land efficiency, how much land space do you need to produce the fuel, the cost of the fuel, how much do you need to adapt the vehicle to be able to handle the fuel, and so forth. And there are a lot of fuels that are not really qualify as a real alternative fuel in the long run. The last aspect is also when it comes to infrastructure and supply of the fuel out on the market. And here, of course, electricity is a really interesting fuel because a lot of the infrastructure is already there. And as you saw, that we are, since 2 years back, renewable fuels, or I should say non-fossil fuels, is more than 50% of the electricity production in Europe, which is really promising, and it has been so for the 2 past years, and it's doubled over the last 5 years. So from this perspective, electricity is a really promising alternative fuel. What are then the challenges to electrify transports? Well, if we take car as a starting point and the personal car as a starting point, there are a couple of challenges with electromobility. One is, of course, that the energy consumption of the vehicle is 5 to 10 times higher per kilometer compared to personal car. It all varies, of course, with what average speed the truck has, long distances it drives, and how heavy it is. On top of that, a truck normally needs to share its energy from driving with some sort of tool, equipment on the truck, some sort of load carrier. A normal box of a truck doesn't need any auxiliary energy. However, if the box is refrigerated or temperature controlled, we need to provide energy from the batteries to the truck itself. There are other alternatives as well, like a refuse vehicle, compacting the garbage and lifting the bins up to 100, 200 times a day. That also, we need to provide the energy from the same energy storage system. And that will, of course, have an impact on the energy consumption per kilometer of the vehicle. Ideally, we should be able to carry the energy on the vehicle for at least one day of operation, charge overnight, and then be able to run the vehicle without charging during daytime. However, that is, with current technology, to some extent very difficult for depending on what type of applications you're running. And here I'm tried to divide the transport industry and the type of trucks into 5 different applications. One is the refuse, rather short mileage, but a lot of auxiliary energy consumption. Then we have city distribution, running around 50,000 kilometers per year, meaning about 200 kilometers on a daily basis. Urban construction, those are trucks that runs a lot in the city centers, providing all the building material, removing a lot of gravel and dirt from construction sites in the cities. They also consume a lot of auxiliary energy, but in many cases, they have the advantage of being able to charge during loading and unloading. Then we start to come into the more difficult type of application requiring a lot more energy, which is regional haul and demanding long haul. Demanding long haul is trucks basically running a lot more dependent on charging infrastructure across Europe. And currently we're not really there. What we are doing is, of course, we're sharing the same technology as the car industry does. And so we will be able to piggyback and benefit from that. Having that said, it means that trucks normally require about 5 to 10 times more energy on the vehicle than a passenger car. Normally today a passenger car has around 30 to 100 kilowatt hours, while a truck a truck on the chart here to your left will need maybe 100 to 300 kilowatt hours, while if we're going to be able to run a truck for about 500 or 600 kilometers a day in demanding long haul, we would need between 600 or maybe 1200 kilowatt hours. That could, with the current technology, weigh about 8 to 10 tons. And of course, that is not feasible at the moment. So out of these 5 categories, where we are today, we see that it's basically the 2 first ones, it's refuse and city distribution, that are the ones that are most suitable with current technology to electrify. Hopefully, we will see fast development of the technology, and so we can electrify also urban construction and in some time regional haul. I think when it comes to demanding long haul, we would need to see a more technological breakthrough before we can get there, or at least we need to see a much more widespread development of the charging infrastructure across Europe. So, not surprisingly, this is where we start. We start in city distribution and in refuse collection. And we will start with our offer later on this year, putting these trucks out on market, starting to sell them. We have developed 2 electrical models, one 16-ton distribution truck, the Volvo FL Electric, and one 27-ton refuse truck, the Volvo FE Electric. Really suitable for transportation in urban areas. Basically what it looks like under the skin is that we have taken a truck, we have removed everything related to the diesel driveline and put in an electrical driveline positioned in the center of the truck. We have what is normally on a diesel truck, there's a lot of components and subsystems to the truck that is driven by the diesel driveline. And as there is no diesel driveline anymore, we need to replace that on these systems with electrical motors, meaning, for instance, we need to produce air. On a truck, we use air for the brake system and the air suspension, so that has been electrified. We have the power steering system that has to be electrified. We've also, of course, need to electrify the climate unit for the cab and so forth. And all those components we put putting what we call a modular power box underneath the cab. And finally, we have our modular battery storage or energy storing system, the battery packs. Our philosophy is that we should not carry more batteries that you really need on the truck. So we have built up a modular system of battery packs containing 50 kilowatt hours per pack, and we can offer those in 4 to 6 battery pack combination, depending on the customer's demand and how far you need to drive during the day, or if what availability of charging infrastructure that you have. We have 2 different drive lines that we have developed. It is a smaller one for the 16-ton truck with a power output of 200 kilowatt hours, which corresponds kilowatts, which corresponds to approximately 270 horsepower, which is more than sufficient for this kind of vehicle. It's connected to a 2-speed gearbox, so it gives really good drivability in a city environment and not too much gear shifting, so it will be able to keep up this pace with the city traffic. On the larger vehicle, we have made it fairly simple. We've taken the same electrical motor and we double it, so it basically has 2. It has a power output of 400 kilowatts, corresponding to about 540 horsepower, which is more than enough for this kind of vehicle. So it drives really well. It's absolutely fantastic. When it comes to charging, as I said, we use the same charging technology as the car industry. We have not developed anything proprietary. Basically, you will find this kind of outlet on all electric cars, or the majority of new electric cars out on the market here in Europe. It's called the CCS2, for those who don't know. And what it means is that you can the 2 comes from that you can either charge with AC charging, basically from the normal AC charge that you have in your house, or you can charge with direct current, which is much faster. On the vehicle, there are onboard chargers. You can basically just connect a cable to an industrial socket. The charging capacity is about 22 kilowatts, which is fairly powerful. It's what you will get out of the 3-phase industrial socket with 32 amps. A little bit stronger than what you have at home, but it's quite common in the industry and in warehouses and so forth. But that will take a little bit longer to charge the vehicle. The alternative is that you have an external charger, the ones that basically is being installed all across Europe, where you can use direct current to charge. Then you can charge with our vehicle. We can receive 150 kilowatts, which is then 7 to 8 times faster than if you would go with AC charging. But it requires an investment of the customer of a charging system separated from the truck. So the most common question that I get when I talk to customers and other people in the transport industry is, how far can you drive an electric truck? And that, of course, it depends a lot. It depends, as I said, on how big the truck is and how much auxiliary load you have. And of course, then how much battery you can specify. But in the best cases, our smallest truck without any auxiliary loads and with maximum battery capacity, 300 kilowatt hours, you can drive about 300 kilometers, which is more than enough for the majority of city distribution trucks today. If you have a truck that requires more auxiliary load, like a refuse vehicle, you will consume around 1.6 kilowatt hours per kilometer, and then you will not necessarily have the same driving distance. However, when it comes to refuse vehicle, those vehicles normally do not run longer than about 100 to 120 kilometers a day, so it will still be enough. And this is why these segments are so suitable for electrifications. The second most common question I get is, how long does it take to charge? Well, as I said before, we have the onboard charger, And if you have a truck with a maximum capacity of batteries, it will take some time to charge. You have 22 kilowatts available and you need to fill up around 180 to 200, maybe even up to 240 kilowatt hours. That will take you between 8 to 12 hours. It works maybe during nighttime, but if you need to charge during daytime, that is of course too long. However, if you then use an external 150 kilowatt off-board charger, you can do the same charging in 1 to 2 hours, which could potentially work during a lunch break for a truck driver. So there you have the different options for charging. So I said that electromobility will have a positive impact on the climate, and there are two levels where this is true. Of course, on the global level, trying to cut down CO2 emissions. There is often a big debate of whether electric vehicles really contribute to reduce CO2 emissions globally. And a lot of it is, of course, depending on what kind of electricity you're using. Is it renewable or is it fossil electricity? What we can see is, once again, with Europe as a base, there's a very positive trend going on here. More and more electricity in Europe is produced by non-fossil fuels. It's not completely renewable, it should be said. About 25% of the electricity in Europe comes from nuclear power. 40% comes from fossil fuels, and the rest is some sort of renewable fuel. And as I said, it has increased tremendously over the past years. A lot thanks to hydropower, but especially solar power that has started to become really cheap, and even in many cases cheaper than coal or oil produced electricity. Having that said, as you can see, the European average of the CO2 footprint for every produced kilowatt hour has been reduced significantly. But you can see that there is a big spread among the member countries, depending on how they produce their electricity today. Here, Sweden is doing excellently well, actually, because we have the lowest CO2 footprint per kilowatt hour in Europe, with 13 grams per kilowatt hour, while the average is at around 300, and some of the worst countries in Europe, relying a lot of coal and oil, they are at 700 to 800 grams per kilowatt hour. This, of course, has a really big impact whether you will really achieve a positive climate impact. But just to show you as an example, using then the electricity mix that we have in Sweden, you can see that it will cost a little bit more going from well to wheel, taking into account the CO2 footprint of producing the vehicle, but also then the tailpipe emissions of running the vehicle. And as you can see with the diesel as a reference here, we have fairly low CO2 footprint on a diesel vehicle, but when it's used using the standard diesel that we have in Europe, we get quite big impact over the life cycle of a typical distribution truck. In this case, 27-ton distribution truck run over about 50,000 kilometers on a yearly basis for 8 years. And the majority of the CO2 footprint comes from the actual use of the vehicle. When it comes to the electric vehicle, as it is today, when we with the electricity mix that we have when producing batteries, which are normally produced outside Europe with a little bit higher CO2 impact of the electricity used producing the batteries, we get an elevated CO2 footprint when we produce a vehicle. However, when we run it on the Swedish average electricity mix, the CO2 footprint of the operation is significantly lower compared to the diesel truck. And if you then run it on totally renewable energy, it's even less. So as you can see here, you would, during an 8-year lifetime, reduce the CO2 footprint with about 400, a little bit more than 400 tons of CO2 per vehicle. And of course, if we scale this up to 100,000 vehicles on European level, it will have a big impact on CO2 on a global level. But then we also, of course, have a lot of local challenges as well. Inside the cities, especially in city transport, we see that the population in the cities are growing. We see that our changed consumer behavior is constantly increasing the transports inside the cities. Other challenges that we see is that the people inside the cities, they demand improved air quality, noise quality, and with that also improved safety for the inhabitants. And I believe here, and we believe that with electromobility we can challenge, we can address a lot of those city challenges and to give a better environment inside the cities. And one is to work with transport efficiency and with consolidations. We see a trend, unfortunately, today that for many reasons, a lot of smaller vehicles are being used inside the cities. And even though they are maybe less noticeable than a truck, they will produce more CO2 and they will take up a lot bigger space out on the road. A standard truck, replacing a standard 27-ton distribution truck today, the ones you normally see out in the street in the cities with vans, you will need about 10 to 11 vans, which will take up about 9 to 10 times more space on the road, and it will increase the CO2 footprint about 5 times. I'm not saying that we should shift all transport into bigger vehicles, of course not, but it would be good to try to do that with at least the type of transports that can be shifted. And here electromobility is an opportunity because it doesn't only provide zero tailpipe emission. One significant important feature as well with electric vehicles is that we significantly reduce the drive-by noise. Up to 45, 50 kilometers an hour, it's reduced by about 10 decibel. In reality, the sense of that is about half, a reduction of half. And with that comes a lot of new opportunities. One of those is running transportations during nighttime. And we have been participating in tests, both in New York, in London, and in Stockholm, where we have taken transports that is normally carried out during daytime, running them with electric vehicles during nighttime. And here we can see a big benefit. We can see that transportation time, delivery times goes down with about 50 to 60%, so it goes much faster. With that, the delivery precision increases, meaning that the goods arrives to the end receiver right on time. The benefit for the customer is that he can reduce his stock because there's less uncertainties when the goods will arrive. For instance, when it comes to restaurants and those kind of things, they are really dependent on getting all the food and the raw material they need during the day right on time. What they need to do to avoid any issues is that they need to keep twice as much in stock to be sure that they don't run out of raw material. With deliveries during nighttime, we know the customer always knows that the goods will be there on time. When we run the vehicles during nighttime, there's less traffic to consider, and by that we can reduce the energy consumption of the vehicle, which is also a big advantage. Of course, there are some disadvantages. and that is basically on the receiver side. You need to be available, of course, but there are a lot of technical solutions for that today, where we can have remotely controlled locks on buildings and those kind of things that is already used today. So that could potentially be solved. Of course, we have the issues with nighttime noise related to loading and unloading. With electric vehicle, the noise of the driving is significantly reduced. However, some of the issues around loading and unloading are still there. But there are solutions being developed for that as well, with more silent carriages, with better material inside the trucks. But with the zero tailpipe emissions, there are other alternatives as well, and that is indoor deliveries. That might sound very far-fetched, but to be honest, it's not so far-fetched. We have it here not far from us today already. I don't know how many of you are aware of, but all material and all goods into Nordstan here in Gothenburg is actually delivered in-house underground. This is actually what it looks like. I don't know if you can see it. But underneath Nordstan, there is a 1.5 kilometer long delivery alley where all the trucks run in and deliver all the goods out to each store. So if we, when shaping the cities of the future, think of this and think of the opportunities of using consolidating goods into larger vehicles, running them through the city during nighttime with the reduced noise, and delivering them in warehouses underneath the stores, just like we do in Nordstan, we can see a significant improvement of energy efficiency, of transport efficiency, and we can reduce the traffic during peak hours, during daytime, and by that we can also, as a result, reduce or increase the safety of the vulnerable road users like cyclists and pedestrians. So, how will electromobility and for heavy-duty transport develop over time? Well, that is the million-dollar question. That is what we're trying to figure out in our roadmaps going forward. There are obviously not. It's very difficult to predict, because what will it take to get a transport company to change into electric vehicles? Well, there are three key factors, basically. One is they want to. They want to have an image of being a company working with sustainable transport. Normally, that is larger fleets, or it's normally even larger transport buyers that, like IKEA, like Nike, like a lot of companies, preferably working with consumer goods. They have a very strong they take a very strong social responsibility and really want to improve their CO2 footprint. They are the ones that initially will drive electrification of heavy-duty transports. The next thing that will get a transporter to change into electric vehicle is because they are forced to. That is legislation. We start to see it. Some cities are already now banning diesel vehicles. Some are planning to do it. They are putting fees on vehicles running on fossil fuels. We have example in Norway where you basically need to pay around 200 Norwegian crowns on a daily basis to get into. Every time you get into Oslo with a standard truck, if you run on zero emission vehicle, it's zero. So there, of course, you will have an advantage of running electric vehicles in Oslo. But then there is a lot of other cities that is starting to legislate and creating diesel bans and emission bans inside their city. So that is, of course, one aspect as well. And then the third one is because it makes sense from a financial perspective. And currently we are not there, and it will change over time as technology improves, as we get more efficient technology, as the costs go down. But also it's very depending on electricity prices. And what we can see now that in Europe there's a quite big difference of electricity prices between the countries, where we up in north of Europe have really good prices, so these markets are more suitable, and we expect to see a more rapid change going to electric vehicles, because it's the difference between diesel price and electricity price that will pay for the larger upfront investment when it comes to electric vehicles. And that's why we believe that gradually we will see a change over to electric vehicles, segment by segment and markets by markets, and that is what we refer to as the elevated adoption phase. Finally, we will see the broad adaptations where it starts to make sense from a financial perspective for the majority of markets here in Europe. Well, that sort of concludes of what we believe, how we see electromobility will come also into heavy-duty truck industry. We embrace it. We really believe that this is something for the future for Volvo Trucks, for the transport industry, but it's also a significant part of the future for our society. So by that, I thank you very much for your attention.